We're continuing our excellent lineup of main stage speakers this morning at Storage Developer Conference with Rebecca Weekly. Rebecca is Senior Principal Engineer and Director of Cloud Platform and Solution Strategy at Intel, where she provides a deep technical understanding of cloud data systems configurations to deliver a $10 billion product portfolio. Rebecca is responsible for looking across cloud compute, storage, networking, artificial intelligence, software, and security solutions. However, in her spare time, I don't know where she has that, Rebecca is the lead singer of a funk and soul band, Sinister Dexter. We got that right? She was professionally trained in dance, and she's an experienced choreographer. So welcome to an excellent presentation from Rebecca.
Or dancing. Not at all. I wish, no. Totally different part of life, but really exciting to be here with you today. I spend most of my time with our customers, with our cloud customers in specific, whether the hyperscalers or customers who are leveraging their own internal clouds. And it is such a great opportunity to sit down with the developer ecosystem and to sit down with the teams doing industry standards, because so much of the complexity that we are dealing with, you bring calm to that chaos. And if we can partner well in the standards bodies, we can really come up with innovative solutions that support multi-cloud and edge and all of the different pain points our customers are facing. And I loved hearing from Scott earlier, just before, because he is the perfect representation of that combination of on-premise requirements, what's happening on client, what's happening in the public cloud, all of it coming together as a pain point. So great experience to listen and hopefully learn, and hopefully I can learn from you throughout this session. So I'm going to start with just an overview of sort of the pain points of data, right? And I'm sure all of you know this, but this is from Raconteur, which is an interesting visual picture of data. What we're looking at here is just the data generated in one day, right now on the internet. That represents over 500 million tweets, 4 petabytes full of exciting information being generated by our customers on Facebook, 294 billion emails sent through public entities, 4 terabytes of data from each connected car, right? Each of these new IoT applications is generating a huge amount of information to be processed. 65 billion messages on WhatsApp, 5 billion searches a day, and by 2025, the estimate is that it will be 463 exabytes of data each day globally. I don't know if you're all ready to build as many wafers as we will need to supply this, but it's the innovation these teams are driving that will make sure our world doesn't melt trying to actually supply, compute, process, move, store this information, right? We've got to be really innovative as a community to address this kind of pain. Another key area and pain point we're hearing from our customers is this concept of data gravity, right? As more interesting applications are occurring in the market, whether that's AI, HPC, areas of media like what our friends in DreamWorks were talking about, this idea of bringing the data to where you are processing it to give users better experiences is incredibly important. But as people who are constantly solving the cost problem of storage to address that 463 exabytes of data being generated in a day, we have to come up with cost-efficient solutions that allow you to store where you don't care as much about performance and move data, keep data where applications need to process on it. And this is a massive pain point and challenge that we are all innovating around right now. When we really think about that concept of data gravity, this was a concept that was coined by Macquarie back in 2010, and it was really that trade-off of latency and throughput, right? Stronger reliance will create a pull-through for one or the other. That's the challenge that we're trying to address in this particular space. So, oh, somebody's getting a phone call. The second characteristic we really see here is that the more data is accumulated on those edge and endpoints, the more pain in moving that information across. Right? This is the network bandwidth. When we sit down and talk about TCO models with our key customers, the backhaul bandwidth is actually the major pain point, and it's regionally very different. Right? We talk about pain a lot in power and power utilization. We talk about it in the cost of the media, particularly memory. But the backhaul bandwidth and connectivity to edge endpoints is a huge problem. So as they are doing more digital services work, as they are doing more AI at the edge, that is really where we've got to figure out the right efficient ways and the right APIs to actually process on that edge rather than backhaul everything to a core data center. So really thinking about that spectrum, right? That rapid growth of data, the concept of data gravity and that pain of it, and then the need to architect and build storage solutions that go from the edge all the way to core data center is the challenge that this community has to address. To do that, to accelerate that, we obviously are working on different solutions. And I'll talk about some of them today within Intel. But I think what we need to work together as a community on is those industry standards. I see no standard for how to do storage processing on the edge. We'll talk about some solutions that we are working on in the software community, but that's an area where this team needs to innovate to solve the problem that Scott was talking about, where we actually want to use GPUs in a public cloud, but we want to have an efficient way of bringing that data to the cloud where they need to process it. Okay, so just to kind of level set on the basic storage trends, right? Everybody in this room probably knows this far better than me, but what I work with and talk to customers about on a daily basis is where NVMe storage is really taking off. This is not to say that hard drives are going away. Everybody likes cheap storage, and hard drives will continue to exist. But we definitely see NVMe storage as a standard building block within our customer base at this stage. NVMe over fabrics is also an area where we're seeing mainstream deployments at this stage. It is increasingly replacing SAS, SATA-based solutions. Now, there's also this kind of new high-end performance in storage that's occurring. And this is where concepts like computational storage, where you're actually doing more of the computation on top of the device itself or on the server that is host for that primary device, is occurring. And this is where we are keeping our eye on it. We are definitely working with our community to drive different solutions, but there's no one recipe. We see different SDN-associated computational storage solutions with one top account versus others. And so that diversity in approach means we don't yet have a single solution. There's not one good architecture to solve this problem, and it's an opportunity for this community, I think, to really influence the market. So again, data storage paradigms, you know this quite well, right? The world has evolved quite a bit. Obviously, block storage is still a primary aspect of how enterprise applications and enterprise databases are running. And file storage is an obvious transition in the market as we've moved forward. But the area where I'll spend more time today is really on this aspect of object storage and how we're really seeing massive innovation in key value structures and in how they're being distributed across data centers out to the edge, and what we can do to help and where we still need, I think, more help in this community. So fundamentally, object storage really is an area where we're seeing the most innovation in the cloud. Now, you can look at Gartner, you can look at many different customers. I'm sure you guys have spoken to many yourselves. What is actually driving their choice on storage? Gartner has their perspective on this: unstructured data workloads, the capacity requirements that are there, the fact that data is not necessarily coupled to an application or is. But these things boil down to cost, data availability, security, and actually, the way of accessing the structure of that data that is being accessed. So as we look at all of these factors, That's really what that set of 4 factors is really what we're trying to disambiguate when we help a customer find a storage solution. Object storage really started in this. If we were having this conversation 5 years ago, we'd really just be talking about these applications, right? We'd be talking about core functions, REST or HTML APIs, what we were doing to help with a specific use case, whether that was a template for VMs or some specific backup or archive, or I/O workloads, right? Is it static content? Is there a low change rate? These are the kinds of ways in which 5 years ago everybody was having the conversation. But cloud has completely changed how customers are approaching this. We can say that a data lake is an example of how that's changing, right? A large repository of unstructured information that's coming from any source, accessible to any end application using something like S3. If you're doing that, you really need to have a well-defined API layer into that disaggregated data lake. You need to have SLAs that are deterministic for the different tiers within that data lake, and a mechanism by which you're disambiguating what has been in there, whether it's log information, whether it's any kind of sensor information for an edge use case, et cetera. There's so much innovation in this community, especially in the hyperscalers, but certainly in all of our, I have a few examples up there, right? Kafka is in there, in terms of how data is being processed and stored within those data lakes, and then how we are accessing that information. It is absolutely key for our customers to build on top of these data lakes and have deterministic SLAs. And I think Scott really did a great job of queuing up that data lake is not even the one that's in your traditional hyperscaler cloud. It's actually a distributed solution from an on-prem cloud into the public cloud. So one of the areas where we are really trying to work with our customers to innovate in this space is DAOS, which is our distributed asynchronous object store. DAOS we announced it actually in June, I believe, at the PMDK Summit. It's something that we started working on for the Aurora supercomputing solution for the Argonne National Lab, which is coming to market in 2021. And what is DAOS? DAOS is really a solution that is it's an open source software defined object store, and it's designed from the ground up for massively distributed non-volatile memory. So DAOS takes advantage of next generation NVMe technology. This can be storage class memory. So I said NVMe, and I really meant NVM. So storage class memory as well as NVMe. So it presents a key value storage interface and provides key features like transactional non-blocking I/O, advanced data protection with self-healing on top of commodity hardware, and end-to-end integrity. And I think one of the key areas that's interesting for distributed computation in specific is that fine-grained data control and elastic storage. This allows our users to make trade-offs optimizing performance and cost, again, fully open source. Now, this is not to replace scale-out storage. Again, nobody's going to come in here and tell you scale-out storage is disappearing anytime soon because of that cost problem for storage choice. But it is about creating high-performance storage solutions, edge solutions, ingress servers, anything in that category that might want to use persistent memory easily and have access to that from the application layer. So this is, again, fully open source. I've got the links in there. I believe it's on the website after. You can go look at this. There's a series of options for you to listen to, webcasts, white papers, et cetera. But we're really excited about bringing this into the market and helping this community build more on top of persistent memory and innovate on key value. Another key trend in the cloud that I think is driving a totally different paradigm for storage is this concept of function as a service. Even a traditional microservices model with containers is really driving differences in storage. When we work with customers across the spectrum on function as a service, one of the key pain points is spin-up latency. Bless you. Spin-up latency or cold start times are really a massive challenge. The whole concept of function as a service is about ephemeral computing, right? I write an application, I put it in a GitHub repo, I have a trigger event that runs that little piece of Java code, and I don't need to think about infrastructure management, right? Access to all of my data is done through an API call. It runs, it does what it needs to do, and I only pay for the computation I need at the time that I need it. And by the way, I pay more for the computation I need at the time I need it. But conceptually, for new use cases, what you'll find is that users are not yet sure how much they're going to run these applications. And so it's a good way for them to experiment before they decide if they want to optimize and bring something into their on-prem cloud or build a more sort of bare metal implementation potentially that could be more cost efficient. So it's a huge area of innovation. We're forecasting that this will be about 30% of public cloud deployment runtime hours by 2023. So there's a ton of work happening in function as a service. And every time we talk to a customer, every time we work with them, security is a pain point, but the number one pain point is this concept of spin-up latency. How do we go faster? Because these are not stateless, ephemeral workloads. They need to know their state. They need access to storage. They're doing inferencing. They're doing rendering, right? Important workloads. This is where we've got a ton of interesting POCs happening with persistent memory. And it's not necessarily the persistence. It's really having a local cache of memory-like content that they can actually grab information from quickly at a better cost structure than DRAM. So lots of interesting work in this space. Really exciting to partner with lots of our customers. I could probably name 15 different ones doing distributed work in this area. But solving this problem for faster state recovery, essentially, for FAS is going to be an interesting area of memory innovation or caching innovation on storage throughout the next few years. So I've discussed a couple of areas where the cloud is innovating, some of the pain points, some of the challenges of going to the edge, and I hope you feel empowered to help solve some of those problems with us. I really want to talk a little bit about, as they're evolving, what can we do to drive next generation storage architectures together. So Intel is definitely doing work in the open source space from software to hardware to try and solve some of these problems. Can't do it alone. We hope for your partnership, definitely. I can hit a few on here. This is an eye chart, but I can hit a few on here, I hope, to help you understand some of the areas that we are working on together. Intel Storage Acceleration Library. How many people out there have used ISA-L? Oh, it is a depressingly small number of hands, because this is like free performance. Please look at ISA-L after this session, if nothing else. I remember being in a conference with my customers in China, and one guy stood up and talked about ISA-L and literally was yelling in Mandarin, but it was translated, at the rest of the team that they were just literally throwing away dollars by not using ISA-L. Customer statement, not mine. What I love about ISA-L is really there's optimized algorithms. It's used to accelerate functions that are very important for storage, right? Compression, integrity checking, hashing, encryption, things you would typically see in most storage applications. But actually, it's so well written. That session that I was in was actually for media. And it was being used in the media space on actually codec sort of how-tos in the compression side. And it's really because ISA-L has done a lot to determine a fast path through the CPU. So an example in the storage domain is Ceph. By default on Intel processors, will actually use ISA-L on the back end for erasure encoding. Other solutions, ooh, I hit the button too fast. I will get into that in a second. So other areas to really think through that we provide into the open source community is the Storage Performance Development Kit. So hopefully folks have used SPDK as well. SPDK Summit happens, I believe, twice a year. We have a lot of different contributors and folks within the ecosystem, and it runs on any processor. This is an open source solution. Of course, it runs best on Intel processors, but it is certainly one that we are really excited to contribute to the community and make sure that you are getting best performance on storage workloads with Intel processors. And of course, one that I think there's a hackathon going on as we speak or throughout the week on the Persistent Memory Development Kit. And again, this is to jumpstart this new ecosystem of applications on persistent memory. and make it easier for you to get started. Two others I'll hit just very high level on this slide and then get into some of the details, is the cache acceleration software solution. So if you've heard of CAS, that is really helping us provide caching capability to accelerate frequently accessed data, accelerate access to frequently accessed data. And of course, no conversation about storage can be had without also talking about the interconnection with compute and network. Right? It's all about accessing the data as you need to get to it, when, where, and how. So there's a lot that we've done within our gigabit Intel Ethernet adapters as well to talk about accelerating storage solutions, and I'll hit that in a couple of slides. We've been talking a little bit about persistent memory. Obviously, SSDs is a huge part of this as well, and a cost-effective methodology to get better performance and caching as well. So we have our second generation of 3D NAND that was optimized for high density that came out this year as well for both data center and enterprise configurations. And then we have the 4600 series, which is really optimized for caching. So super low latency, high bandwidth that is really intended for cloud environments. All of these drives, of course, we're talking about data integrity solutions, reliability solutions, and performance consistency that you would expect from an Intel processor and an Intel SSD. So you may be wondering why I'm talking about vector extensions in a storage conversation. What does floating point have to do with storage? And the answer is nothing whatsoever. But AVX512 actually supports high-speed bandwidth vector pipelines for integer operations as well. And those are used by storage systems all the time. All the time. So this is what is really exciting to us about efficiently moving and processing data. So the XOR operations that are in ISA-L actually use AVX512 in the latest Skylake processors and beyond, CLX as well. So what you're seeing in these performance results, I always hate to point to performance results in a slide, but there you go, is actually a massive increase in performance with ISA-L using AVX512 to accelerate software libraries. P plus Q, right, the PQ generation for RAID 6 calculations. Also, and for folks who are not as familiar with that, I'm sure everybody in this room is, but when you have two media failures without losing data, or one failure and somebody pulls a drive when they didn't intend to, or you didn't intend for them to, that's one of the reasons why we use RAID 6. You'll see we have very exciting performance improvement results with that as well, using AVX512. And the last one is, I think, the most exciting. It's the Reed-Solomon erasure coding, right? That everyone probably is very familiar with Reed-Solomon erasure coding. This is really for protection and integrity, so simultaneously in a scalable manner. So again, I'm sure that this is not news to anybody, that erasure coding has nothing to do with wiping data, but from a branch of mathematics. And its hashing is used all the time in storage, from file system layout to deduplication, compression, et cetera. And in all of those, AVX512 actually has a huge improvement. So across the board, we actually are seeing for storage, the Skylake processors, the CLX processors have a ton of performance available to you in that the integer operation side. So we've done a lot of work to enable that. It's in ISA-L. It's in all of the development kits that I mentioned before. So please do take advantage of free performance. I don't know why you wouldn't. So want to hit a little bit on this concept of Intel storage solutions and this real spectrum of performance and storage and memory solutions. We continue to expand the offerings here. And that might seem confusing at times. Sometimes it feels a little confusing, I think, to the market. But it's really because we have such a spectrum of needs, like we were talking about at the beginning, right? When you're going from the cloud to the edge, you may have very high performance required, real challenges around form factor, where we need to get very dense and low power, but with a lot of accessible information. Think use cases like CDN, right? A CDN is a big storage box that's running Nginx on top. I mean, it's just a big storage box. but it's in a very dense configuration, often in a co-location facility, often not secured, right? We need to make sure that those systems can run effectively with the same software strategies as what's running in the core data center. So it requires a range of solutions. So at the top of the storage side, I just want to hit a couple. We have this 4800 series of SSDs, and these are actually dual-ported SSDs. So 2 PCIe buses at the same time being accessed. And of course, that's exciting for storage arrays, right? If you really want to be immune to any single point of failure, you want to have 5 or 6 nines of reliability, you need a dual-port process. So this is really, ultimately, we're getting about 30 seconds of downtime annually from this configuration of an SSD. Now, you may ask me, why are we talking about dual-ported SSDs at the same time that we're adding memory, DC persistent memory solutions? But memory is not serviceable inline anytime soon. So there is a reason to have an SSD that is dual-ported and serviceable in-field, and a reason to have a local stash of persistent storage available to you in that memory footprint. So one of the things that I'm most excited about today, and actually I was chatting with Mr. Pappas before we started here, who's going to head over to another meeting and conference for CXL announcements later today, or maybe it's a seminar, a panel that he's going to be on later today about CXL. This is, I think, one of the most interesting new standards efforts Intel has spearheaded, I would argue, since PCIe. You can keep me honest. I have been so excited, and our customers and our community has been so excited about this step into the open source community. So what is CXL? It's the Compute Express Link. It's really about enabling computing in a disaggregated fashion, in a standard disaggregated fashion across vendors. And Mr. Pappas tells me it's already public that not only is this Intel, and not only is this Microsoft and Google and various other players across the ecosystem that are key customers for us, but AMD and ARM have also recently, and IBM Power have all recently joined the CXL consortium. So this really is, we believe, the standard interface by which you will do coherent accelerator computation in the future. And when we talk about accelerators, it's not just GPUs, folks. It's computational storage. It's everything that we've been talking about throughout this. In fact, infrastructure acceleration is the most frothy, if you want to talk about it, conversation that we have with our customers. And why is that? Well, application acceleration is incredibly important. Application acceleration is very explicitly called by a user. A user is going to make a determination, I want to run on a GPU. I want to run on FPGA. And in fact, they have to, right? The application itself has to be compiled for that new architecture. Infrastructure acceleration is all about a hyperscaler managing their own footprint, their own cost. It's free money. The more you do that work, the more important, the more effective, the more efficient your data center operates at. It also enables new computing paradigms. So think about what Nitro did with their second generation, where they can do a bare metal interface using an SDN offload card, right, where the entire storage stack, the entire infrastructure management, the VMM layer, the security layer is all on that card. It's no longer on the CPU. The CPU is hosting VMs, or it's hosting a full bare metal stack. It's consistent, and user traffic is obfuscated from what is happening on essentially a control plane processor for the hyperscaler themselves. The more we enable this in the ecosystem, the more standards like CXL enable that kind of activity, the more efficient our hyperscalers can be, and the more the software stacks that our users are creating will be actually accessible out to the edge. So I think this is a great, super exciting time. I generally get pretty excited about our technology and what these people in this room do, right? This is how we're going to innovate as a community to drive a whole new world of heterogeneous compute. And the most important application to solve is the one that is the crazy cost center, which is storage and network. I love GPUs, they're very exciting. I'm not trying to say anything negative about GPUs. It's just, this is really the core of running a data center. It is the number one pain point we talk to about with our customers. And coherency is key. And that's why CXL is so exciting. So I get very excited about it. That's not surprising. If you're familiar with CXL, if you're not familiar with CXL, you can always talk to Mr. Pappas. But what we're really trying to do there is it's a protocol layer, right? It's a coherency protocol layer. It's running on top of PCI Express Gen 5. So you're getting that doubling of speed that goes from Gen 4 to Gen 5, and really allowing you to have coherent memory space between the CPU and any installed device off the link. So whether that's GPU cards, whether that's what we were just talking about, infrastructure compute accelerators, it's going to be a really interesting time. And we already have a series of proofs of concepts with different customers leveraging UPI attached, FPGAs today, innovating and starting to play in this space, and it's just going to continue to take off, which is super exciting. So the CXL consortium, the SIG, is fully established. It has lots of giants in it: Alibaba, Cisco, Dell, EMC, Facebook, Google, HPE, Microsoft, IBM, AMD, ARM, lots of really wonderful folks involved and playing in this ecosystem. And I hope you will participate as well. There's 82 or something. 87 participants. So really, this is where standards work best. This is where we drive a whole new world of innovation as a community for heterogeneous compute. So I'm a little excited. Okay, so what is Intel doing to try and help you with performance, workload placement, and really getting more out of the hardware, the commodity hardware you buy? I can talk about, I've already hit a lot of these software stacks, but SPDK, this is where with NVMe we saw a 5x improvement on FIO. So this is measured on FIO. Great speed test, most people have done it. SPDK gave us 5x, that's about 7.8 million IOPS per core. And I bet if we do our work together and keep tuning, that can be 10 million. There's no reason not to. If you look at Ceph, we've done with CAS, I mentioned this earlier, CAS framework tuned for Ceph. We gave about 5x improvement using Optane DC SSDs. On Cassandra with a key customer, we actually were able to drive an 8x database performance increase using persistent memory. Now, persistent storage we can talk about, but persistent memory solutions. We actually gave them also a 3x TCO advantage by reducing the number of servers they needed to have for that encapsulated storage content. And the last one, which isn't as big a number, but I think it really is when you think about the world, we were able to achieve with vTune amplifier on Netflix a huge improvement of about 2.2x on their streaming workloads. And that matters, I think, in the world of compute when you realize that 30% of all internet traffic every evening is Netflix. So if we get them 2.2x more efficient, that helps, I think, the world, right? Fewer data centers, a little less power used. If you aren't familiar with vTune, we actually have done a huge amount with vTune Amplifier. We released this, I want to say in February of this year. Keep me honest, Dan. I believe it is February of this year. The latest version of vTune. vTune Amplifier now supports DC persistent memory, so you can use it to understand hardware configurations out through the memory bus and help optimize software. So that is how we were able to do this work with Netflix. And that actually was so important to Netflix as a user of Amazon that we ended up partnering with Amazon to expose exactly these same features in their public cloud. So it is really, we have these pretty graphics that talk about core to edge and these different use cases, but that's an exact example of Netflix's own CDN servers, how we were able to deliver more performance, and then how we were able to move that into a public cloud flexible model that actually supported our users better. So in this storage conversation, no storage conversation is ever complete without talking about the criticality of the network and the level of innovation that is required to actually be effective doing storage at scale across core to edge. You may be aware that in July of this year, we closed an acquisition of Barefoot Networks. Currently still a separate business unit, but absolutely complementary to our overall network portfolio. And what I'm showing here is really just a typical hyperscaler connectivity point, right? So we've got our different top-of-rack switches over various servers, and those servers are usually optimized for different use cases, right? We have a standard compute storage server. We have, accelerator pools available to us, usually with different connectivity between the storage and the accelerator pools as we would for a standard sort of server. This is why innovation is so important across this portfolio and together. Depending on that network connectivity, whether it's a fully routed Clos or a folded Clos network, you may have significantly more bandwidth in your rack than you do across your spine. And so workload placement really matters. And our customers are optimizing at that node level to make sure they're doing the right things to get to their storage tier for their specific applications. You may know that we introduced, I believe in March of this year, our Columbiaville Ethernet 800 series. And this is where we actually have brought to market a 3-in-1, right? The ability to do iWarp or Rocky V2 on top of our standard Ethernet adapter and support various fabrics on the back end. So really excited about how this actually simplifies hardware choice and selection in the network adapter card to support storage. But what are we doing specifically with the 800 series for storage? The one I'm most excited about is application device queues. So to use a simple analogy, right? Typical TCP, everything's all on the same bus all the time. It's just a big old mess, right? And one of the reasons why RDMA is so exciting is that folks can be a little more specific about congestion control and management. What you can do with ADQ on top of standard, just standard TCP, NVMe TCP, is you can actually direct, so lower is better. It's not typical here, but lower is better. With TCP ADQ, you're seeing about the same performance characteristics on the bus as an iWarp or a Rocky V2 implementation. And this is just standard ADQ application, really exciting for us. So in case you are interested in learning more, it actually has been released for comments this week. So we're working actively to upstream ADQ into the Linux distro. I hope that you'll be part of the community participating in driving comments and getting this to closure, because it absolutely will allow the entire community to get better performance on standard networking appliances. It's hopefully our goal. So I won't spend too much time because I know I'm getting the hook very soon. But to go back to that network topology conversation, when we really see these different customers with folded or fully routed Clos networks, you see a very different storage design. You see a very different orchestration and workload placement paradigm, and a very different desire for offload and acceleration on the infrastructure side. So Facebook did a great conversation or a great post around their fabric networking solution. And what it really showed was the east-west bandwidth congestion. And most of that is actually internal logging, data structures, storage. It's the stuff that gets generated. They said 92% of the traffic was the intra-traffic, not the inter-traffic out to users, right? It's all of the stuff that we are trying to store and collect and manage that needs to actually be processed. And similarly, we're seeing with other customers going to, instead of that tiered structure, where they're controlling network cost and caching more locally to help ensure they have the highest sort of performance for their end solutions, the fully routed Clos, right? And these are where they're trading off and they're saying, we'll spend more money on networking and we will have storage pools and we'll get less stranded capacity, but you have to have a very, very fat pipe to feed that and a really good methodology for orchestration and management. So we're seeing both extremes in hyperscalers, all kinds of hyperscalers. And each one requires a different storage topology, methodology, and management. And that's why it's so important to have very fast local store, whether it's persistent memory or Optane DC SSDs, or standard SSDs, hard drives, etc. Right? There's a whole spectrum here. It exists for a reason. There's a totally different network topology. Out of all of this, my true call to arms are standards. Standards really do help us, and I'm so glad to see this community here together. Standards bring calm to the chaos. I said it before. Intel's incredibly committed to this community. We have so many folks sitting in this room, whether it's Jim or Alan, Jenny, all helping to drive these standards together and to help us make better products to solve the complexity of this ecosystem. So I know I got my 1 minute. It's time. So thank you so much for your time. We talked across kind of the nature of compute, network, and storage from the edge to the core, how those are interrelated, how we can use standards to help, what the different software solutions and technologies are that Intel is bringing to market, including tools like vTune to help our customers get best experience across that ecosystem. And I hope that we can work together to do even more in the next year. Thank you so much.